Hi you guys, so we're going to try this back. I'm hoping uploading things as PDFs is going to work a little bit better, but we'll see. So in section 2.1, we're working on solving one-step equations. So I want you to define all of these in your notes. So pause it, go back to your book, start that now, and then we're going to start to go through some problems. Okay, so hopefully you were able to do that. I'll check for those in the note check, so to make sure you're doing them. So our first examples that we're going to do using solving using subtraction. So in here I have x plus 13 equals 27. And when I want to solve this, since 13 is a positive number here, I want to isolate x to be all by itself. And our main rule that we're thinking of here is that if we do something on one side of the equal sign, we have to do it on the other side, okay? So in order to solve this equation for x, I'm going to subtract 13 from this side, right? That would get x to be all by itself. If I have plus 13, the opposite would be to subtract 13. But I must also do that from the other side. So if I do that, I would have this x is just going to go down, right? We didn't take anything away from that. Positive 13 minus 13 would be 0. And then I would have 27 minus 13, which would give me 14. So we would write x equals 14 as our final answer there. Okay, so B, this one's just a little bit different because we have 15 plus x. Remember for addition, we can switch those. So if it helps you to switch it to be x plus 15 equals 20, you can do that. And then it looks like the one that we did in A. So I want to get x all by itself. And so since I have x plus 15, I want to subtract 15 from both sides. And that'll cancel this, and then I have 20 minus 15 on that side, which would be 5, so I get x equals 5. Okay, let's try these ones right here. I'm going to zoom in a little more so I can have more writing space. Okay, so I have x plus 3, or 14 equals x plus 3. I want to get x all by itself, so I'm thinking, what do I need to take away from this side? And I need to, and we could write it like this if you would rather, add a minus 3 to both sides. So then this becomes 14 minus 3 equals x plus 3 minus 3. Now if I solve that, 14 minus 3 is 11, and then I have x, and then if I have plus 3 minus 3, that's 0. So I end up with x equals 11 as my final answer here. Okay, on D, I have 12 equals 13 plus x. So again, there's a few different things. I can flip-flop these. Addition doesn't matter what order we solve them in, so I could write this to be 12 equals x plus 13. And I can solve it how I did above, but we can always flip-flop things on either side of the equal sign. So if I wanted to do that, I could put x plus 13 over here equals 12 right here. And so then to isolate x, if I have x plus 13, I need to subtract 13 from both sides. If I do that, I get x, and then 13 minus 13 would be 0, equals 12 minus 13 would give me negative 1. So then my final answer is going to be x equals negative 1, like that. Okay, so the next kind of the next kind of problem is going to be solving using addition. So again, we still want to isolate that variable. We are working to always get the variable all by itself. So if I'm looking at A here, I'm going to solve this using addition because the problem says negative 7 equals B minus 3. So to get B all by itself, I need to add 3 to both sides. So if I do that, I have adding 3 to both sides. Then I can do negative 7 plus 3, that should give me negative 4, equals B, and then negative 3 plus 3 is 0. So my answer would be b equals -4, just like that. So similarly, in this example here, I have 4 equals x minus 5. We didn't do it in the first one, but you're totally welcome to swap those things if it just helps you for organizational sake. I can swap the things that are on the sides of the equal sign. That doesn't change the solution at all. It doesn't change the problem at all. So to get rid of the x minus 5, I'm going to add 5 to both sides. Okay, and if I do that, I get x equals, this cancels, 4 plus 5 is 9. So then my solution would be x equals 9. Okay, for C here, same kind of thing. Y minus 16 equals -20. I can get y all by itself if I add 16 to both sides and turn that to 0. But whatever I do on one side, I have to do on the other side. So I'm going to add 16 to both sides. Then those cancel and I should get y equals, and I have -20 plus 16. So -20 plus 16 gives me -4. And I should have y equals -4 as my solution for that one right there. Okay, D says a minus 10 equals 3. Same thing. I want a by itself. I want to isolate a, so I can add 10 to both sides. And then I get a, those cancel, and 3 plus 10 is 13. So I'd have a equals 13. Oops, oh, there you go. Okay, so the ones I want you to try are going to be this one right here. Oh no, don't do that. Right here, and right here. So pause the video, try those, and we'll go over them. Okay, hopefully for trying those for this one right here, you subtracted 2 from both sides, and you got y equals, remember, -6 minus 2 would be -8. Okay, right here, m minus 8 equals -14. I should add 8, do the opposite thing. M equals a -14 plus 8 would give me 6. So I get +6 for that one. And here I'm going to add 3 halves to both sides. And remember now, if I have 1/2 plus 3 halves, and this is addition, not multiplication, I can put them both over 2 since they're over the same thing, and then I have 1 plus 3 on the top, which is 4. 4 over 2, that simplifies to be 2. So y equals 2 here. Okay, so now we're going to do division and multiplication. So hopefully this is somewhat of a review and you guys have seen these before. But let's start with example 3 where it says to solve these using division. Okay, for A, I'm sorry this is blurry a little bit, it says solve 4x equals 6.4. Now, if I wanted to get x all by itself and I have 4 times x, the opposite of multiplying would be dividing. So I'm going to divide both sides by 4, right, because those will then cancel. And if I do 6.4 divided by 4, we can do a quick review, right? If I did 4 divided by 6.4, right, 4 goes into 6 one time. 1 times 4 is 4. So I get 2.4. 6, and we can ignore actually the decimal point, sorry. Let's just do 24 here. And then 4 goes into 24 6 times, but I have 1 decimal point, so I need that. So I get x equals 1.6 here. Okay, B, same thing. It says 8 equals 4x. So 4 times x. The opposite of multiplication is division, so I'm going to divide that by 4. That cancels out. 8 divided by 4, I hopefully would get 2. So I get 2 equals x, or x equals 2 as my final answer there. Okay, for C, it says 25x equals 5. Remember, this is 25 times x equals 5. So now I want to divide by 25, right? I want to isolate x to get it all by itself there. So those cancel, and then I have x equals 5 over 25. So let's simplify that. To simplify that fraction, we want to see what the top and bottom are both divisible by. And in this case, the biggest number that they're both divisible by is 5. So if I do 5 divided by 5, I get 1. 25 divided by 5, I get 5. So I should end up with x equals 1/5. My final answer there. All right, for D, 50 equals 10 times x. I want to isolate x, the opposite of multiplication, so the 10 times x, I can divide both sides by 10. And that cancels those. 50 divided by 10. Hopefully you get, if you wanted to simplify the fraction, both those are divisible by 10. So 50 divided by 10 is 5 and 1. 5 over 1 is just 5. So 5 equals x, or we can write it as x equals 5. Okay, so try A and B here by yourself, and then we will go over them. Okay, here, same thing. We see 10 equals 15 times x. If I have 15 times x, I need to divide both sides by 15. So I have 10 over 15 equals x, but that's not the most simplified form of that fraction. So I can do 10 divided by 5, which would be 2, and 15 divided by 5, which would be 3. So I'd have x equals 2/3 as my final answer there. Okay, ooh, that one's a little way blurry. Negative 3.2 times x equals 14. Same thing, we're doing divided by negative 3.2, divided by negative 3.2. Then I can cancel this, and I should get negative 4.375, and it's negative because if I have a positive and negative that I'm multiplying or dividing, I get negative. Okay, so the next thing it says to solve, with multiplication. Okay, so here, to solve with multiplication, right, the A says x divided by 4 equals negative 9. So if I wanted to do the opposite of dividing by 4, I'm going to multiply by 4 on both sides. That cancels this, so then I'm left with x equals negative 9 times 4, which is 36. Okay, so there's that piece. Let me rewrite B here. It's supposed to be s over 10 equals 3, but that also kind of looks like a 5. Let's just maybe change it to, I don't know, x or something, so it's a little easier to see on here. Okay, x over 10 equals 3. X divided by 10. To get x all by itself, I need to multiply by 10 on both sides. So let's cancel that. Then I have x equals 3 times 10, which is 30. Okay, for C, negative 4 equals m divided by negative 4. Hopefully you guessed it. We're going to multiply by negative 4 on both sides. Okay, because multiplication will cancel out the division. On the left-hand side, I have negative 4 times negative 4. Remember, a negative times a negative is a positive, so I get 16 equals m. Final answer there. All right, D, hopefully you're able to see it's the same thing. 5 equals x divided by 3. To undo the division or to get x all by itself, we're going to multiply by 3 on both sides of the equation. What we do on one, we must do on the other. Cancel those, and then I'm going to have 15 equals x. Okay, so try these ones by yourself, and then we'll go over them. All right, first one. So 19 equals r divided by 3. Hopefully you multiplied those on both sides. If I wanted to 19 times 3, I can do it like this. 9 times 3 is 27. 3 times 1 is 3. Plus 2 is 5. So I get 57 equals r, like that. Okay, here, x divided by negative 9 equals 8. Hopefully you remember, when we have division, we need to multiply both sides, so it cancels those things out. Then I have x equals 8 times negative 9. A negative and a positive is going to be a negative number. 9 times 8. 72. Sorry, my daughter just dropped something over there. Okay, so we're going to go over the reciprocals in class together the next time we meet, but this is it for section 2.1.